Hello everyone. It is a great honor for us to introduce our paper, titled, Realigning Language to Visual Objects with an Agentic Workflow. The emergence of LLMs has elevated agent research to new heights. Current agent applications, like Manus, focus on developing assistants to enhance human productivity, but we believe agents hold a deeper value paradigm. They can establish workflows that serve as a flywheel, sustaining high-value data assets across AI industries. In our paper, we demonstrate this potential through an application of agentic workflows in multimodal domains. Specifically, we show how such workflow can provide data with high visual language alignment quality, enhancing the performance of corresponding AI models. To help readers understand our work, we would like to introduce some backgrounds first. The target task of our workflow is language-based object detection, which aims to align language data with visual objects. Unlike traditional object detection, which uses coarse nouns or short phrases to represent the object, the LOD task focuses on describing objects with longer and fine-grained language data from more perspectives. To tackle these challenging expressions, generative models have replaced discriminative models since the breakthrough of CLIP. These frameworks independently encode data and then interact to decode results, which demands vast training data, a costly endeavor, such as OWL. In addition, diversity of expression is essential, but the simplistic language and training data limits the model's ability to handle complex expressions. Although introducing VLM to generate expressions automatically is promising, it still brings some problems. When dealing with small objects and using unspecific prompts, the VLM may misperceive objects caused by hallucination, damaging the alignment quality of the generated expression. Fortunately, this can be alleviated through appropriate operations. For example, cropping the input image allows the VLM to recognize the union flag accurately. Similarly, asking for specific details, like the color of a person's clothes, ensures a more accurate identification. Motivated by this, we propose our Real LOD. To improve the alignment quality of large-scale VL data, we propose an agentic workflow named Real LOD, which involves steps, planning, tool use, and reflection. The input is the generated expression after filtering, along with the image and other relevant information. Real LOD first reasons its current state and arranges action. These actions are then executed using tools for object ray description. Another LLM analyzes the refined expressions and provides feedback. These steps are conducted in a cyclic form to improve alignment quality gradually. Specifically, we design 5 states and actions from 6 aspects according to the analysis of misalignment. It is notable that Real LOD adaptively adjusts the language and visual prompts to reduce hallucinations caused by VLM. For a clearer explanation, we provide an example of our workflow. Suppose an image contains a group of people on horseback in a forested area, and the target object is marked with a red box. The VLM misperceives the target object as brown horse walking on sand. Our Real LOD successfully corrects this wrong expression to brown horse walking on dirt path. How does Real LOD achieve this? In the planning step of the first cycle, our agent reasons that it is uncertain if the horse is walking on the sand. Hence, it crops the object region with its surroundings, and builds a specific text prompt for VLM to perceive further. Then, the VLM outputs the supplementary information during the tool use step. The reflection then identifies the misalignment of the given expression. Based on feedback from the first cycle, a rewriter is called to correct it during the second cycle. Finally, Real LOD reasons the realigned expression as correct and ends the workflow. We also conduct extensive experiments to investigate the effectiveness of our method. First, we analyze the data after realigning and compute the success rate. As shown in this slide, our workflow can successfully handle the 6 misalignment aspects. We also conduct ablation studies to evaluate the effect of filtering misaligned expressions and applying Real LOD to realign them. We then provide quantitative comparison on Omnilable and DOD, which are current popular LOD benchmarks. With the realigned data, our model achieves SOTA performance in description AP. The performance on RefCoco and OVDival benchmarks also outperforms other methods. This demonstrates that the alignment quality of VL data is a critical factor in improving LOD models. We also provide some visualization results. Intuitively, our real model can better deal with complex and long expressions. For more details, please refer to our GitHub and main page. Thanks for your attention.